So let me continue with the description of your diuretics. Now I have said you the various physiological changes whatever are happening at the various parts of the nephron. Now let me give you the definition of this particular diuretics. Remember, diuretics are those particular substances whenever you induce or whenever you give them into any biological system, these diuretics, they will increase the urine output. They will increase the urine output. And we have two terminologies. One is diuresis and the other one is natriuresis. Diuresis and natriuresis. Now what do you mean by this diuresis? Diuresis is the excretion of water in the form of urine, whereas natriuresis, it stands for the excretion of sodium, and along with the excretion of the sodium, water is being taken out. That is called as natriuresis. Diuresis is only a free water excretion in the form of urine, whereas natriuresis, along with sodium, the water is also being excreted out. That is your natriuresis. Now, before going into the detailed description of the diuretics, now let me first discuss what will be the number of nephrons which are present within the kidney and what will be the normal renal perfusion. Remember, you take the kidney, right? We have the two kidneys or a pair of kidneys, and the structural and functional unit of the kidney, it is your nephron. Right? The structural and functional unit of the kidney is nephron. Now you take the number of nephrons what we have in the individual kidney. Remember, the number of nephrons is approximately around 1.2 millions per kidney. That means a total of 2.4 million nephrons will be there in an individual, right? So if we take one kidney, it is around 1.2 millions of nephrons are there in an individual kidney, and if you take both the kidneys, they include 2.4 millions of nephrons will be there in an individual. Now it is your nephron which plays an important role in the maintenance of the fluid balance of your body, in the maintenance of your electrolyte balance of your body, in the maintenance of acid base analysis of your body. So it is nephron which plays an important role in the maintenance of all your homeostasis. Next, now to this particular kidney, right, what we require is the renal perfusion. Now you take, this is our 4-chambered heart. Our 4-chambered heart will give a cardiac output of nearly around 5 to 6 liters per minute. Right, the 4-chambered heart will give a cardiac output of nearly around 5 to 6 liters per minute. Now, out of this 5 to 6 liters per minute of the cardiac output, how much the kidney is receiving, right? How much the kidney is receiving. So the kidney, it will receive 20 to 25% of the cardiac output, right? 20 to 25% of the cardiac output from the heart will go to the kidney. That will be the normal renal perfusion per minute. Now you take this 20 to 25%. 20 to 25% includes nearly around 1 liter per minute, right? The kidney, it is receiving 1 liter of the renal perfusion per minute. So that is, so you take this as the nephron, and this will be your afferent arteriole, and this will be your glomerulus, and this will be your efferent arteriole again. So nearly around 1 liter will be your renal perfusion out of your 5 to 6 liters. Now remember again, in this particular 1 liter, it is not completely the fluid which is being present. Out of this 1 liter, 60% will be fluid and 40% of it will be cells. Right? In 1 liter of the blood, we have 60% it is being present in the form of the fluid, whereas 40% of it will be the cells. Now you take this 60%, 60% will be nearly around 600 ml, right, will be nearly around 600 ml. Now 600 ml of the plasma, right, 600 ml of the plasma will try to pass through all your 2.4 million nephrons. Now out of that particular 600 ml per minute, how much amount of the fluid will be filtered from the glomerulus to the Bowman's capsule? It is around 120 ml. The fluid which is being filtered from glomerulus to the Bowman's capsule, it is nearly around 120 ml per minute, right, it is around 120 ml per minute. The remaining fluid, whichever is not being filtered, again it will go to the efferent arterioles and it will go into vasa recta and it will go into the circulation. So that 120 ml of the fluid, whichever has been filtered from glomerulus to the Bowman's capsule, that is called as a glomerular filtration rate. That is called as the glomerular filtration rate. So remember, the normal glomerular filtration rate is how much? It is around 120 to 125 ml per minute in a normal individual. Now remember the next point. So you take, now how much of the fluid is filtered from glomerulus to the Bowman's capsule? Nearly around 120 ml, right, nearly around 120 ml. Now this entire 120 ml will not be excreted in the urine, right, this entire 120 ml, whichever has been filtered from glomerulus to the Bowman's capsule, will not be excreted in the form of urine. Out of this 120 ml, remember the nephron, your nephron will reabsorb nearly around, right, nearly around 119 ml. Right, out of 120 ml, the renal tubules will reabsorb nearly around 119 ml of the fluid. So only 1 ml of the fluid out of this 120 ml will be formed as urine, will be formed as urine. Alright, so remember a point here now. So the amount of the urine formation in 1 minute is around 1 to 1.5 ml. The remaining fluid, whichever has been filtered in the form of glomerular filtrate, will be reabsorbed in the various parts of your nephron, either from your PCT or from your loop of Henle or from DCT or from collecting duct. It is only 1 to 1.5 ml per minute will be excreted in the form of urine. Now, so this is the basic urine formation in a normal individual. Now you see here, whenever you are giving diuretics, what these diuretics will try to do? Diuretics will try to increase the urine formation. Alright, diuretics will try to increase the urine formation. So diuretics are those chemical substances which will increase the urine formation, and thereby they will reduce the fluid overload in the individual. Thereby they will reduce the fluid overload in the individual. So this entire thing is the basic concept, like what is happening in a normal individual, and whenever you give diuretics, what will happen. So whenever you give diuretics, what will happen? The urine formation will be increased.